And finally, here we are today. I'm really happy to introduce Gianfranco Rossi from Ojo Público, which is a newsroom in Peru. And Gianfranco will tell us about how they built an algorithm that helped the newsroom investigate government contracts and unveil corruption cases in Peru. It's the first of our case studies track in this festival, and we're really excited to start with Gianfranco and an example from Latin America, also as a really important way for us to show how global the project is and how innovation with AI is coming from around the world, not just from London, not just from the US or Europe. So I'm really excited to welcome Gianfranco. So at this point, I can stop sharing my screen and get to it. So Gianfranco, I think for the next 30-40 minutes, the floor is yours. We're really excited to have you. Thank you for joining us. And thank you also to Nelly from your newsroom who made this possible with her introduction. So I will stop my blubbering and on to you.
Okay, let's start. Thank you, Mattia, for the introduction and for the opportunity to present this project. Our project, FUNES, is an algorithm for detecting corruption in public contracting. We're going to see what detecting means, what corruption in public contracting means, and also go deeper to the idea of algorithm. So this is the front page for the project that was published last year, FUNES, an algorithm against corruption. And the algorithm gave us as a final result a risk score, a number that tells you how risky a contract is for 245,000 contracts. These contracts were issued by 3,000 state entities and awarded to around 60,000 companies. So the illustration kind of summarizes what we hoped the algorithm FUNES would do for us. And it is that from this vast amount of data, that it would show us the most important contracts for investigating. So I have divided the steps of building FUNES, the algorithm, in 4 steps. It's inception, which comes from Ojo Público, like who we are and what we were doing when we got this idea. The design, how do we even start building an algorithm? The data part, that it's getting concrete, like whatever we want to do in this, whatever we want to do in building an algorithm is limited by data availability and quality. And finally, the results part, how do we validate it and interpret the output of the algorithm? So let's go. Ojo Público is a Peruvian newsroom. It was founded in 2014. So by the time we started FUNES, it was 4 years old. The biggest data project we had worked on was called Fondos de Papel. It was about following the money on political donations. So this is part of the interface of Fondos de Papel. And this logo is from a big traditional party in Peru called APRA. And we were tracking the donors to the political campaigns of this party, and their links with money laundering, with environmental crimes, with drug trafficking. So in order to do this, we had to integrate various databases and to clean them. And this was a previous experience to FUNES, and in that moment, it was really hard to do. But we were already working with big amounts of data. So the next part of the context is the Peruvian context. In these years, the biggest corruption case in Latin America was Lavajato, which was a group of of Brazilian construction companies that had bribed government officials, even presidents in various countries in Latin America, including Peru. So the four last presidents of Peru were involved in something with this company, and it put public contracting on the public eye. And that's part of the context, both internal and external to Ojo Público, is the team. So the main team behind Funes has been Nelly Luna, founder of Ojo Público and editor, Ernesto and Yanko, and Ernesto Cabral and Gianfranco Guaman, both of them journalists, and me, that I'm trained as a statistician. So I want to tell you a couple of stories about Ojo Público to illustrate how is it inside. This is a screenshot of an internal interface that we use. It's called Lisbeth, like a character from these books. I think it's called the Millennium series. I haven't read it, but all the team has. And it's about a hacker and a journalist that investigate together. So the story behind this interface is that we had all this data from fondos de papel that we had gathered in order to make the investigation, but it was there in the database. And Ernesto, and so we were working on other things, and Ernesto began asking me like, "Hey, I have this list of IDs. Can you pass it through the database and tell me if there is any match?" And he would do this like every day, once or twice. So I was getting distracted from my work on that moment, and I quickly hacked an interface to the database. And so it would he could upload IDs himself, and it would show him the results. And yeah, we began using the data like in a day-to-day basis to investigate not only a big investigation, but also when profiling someone or a company. And I remember when we were having lunch or going out to drink something, sometimes we would just begin talking about the possibilities of working with data. So we were always like imagining what we could do with the data we had or what data we could get. And so one day Nelly just called us and told us about this idea to make an algorithm for detecting corruption. So we began brainstorming, like, how would it be? How would it be? How would we get the data? And we realized that we didn't know how to make it. Right? We had to research previous experiences from other journalists and read academic research. So this was the design part. We had to answer the question, what is corruption? So so there are many definitions, and we need to be specific. For example, we can imagine a congressman or a political party in Congress passing a law that will benefit its donors or indirectly the Congress people. So that would be understood as corruption. But in order to make an algorithm, we have to be that corruption needs to be expressed in data, and we have to be much more specific. So going to public contracting, for example, there are at least two modalities. One is what we call collusion. That is when you have in public contracting the state entity that is issuing the tender or the contract, and the companies that are looking to provide for that contract. So collusion is when Collusion is when the company has influence over the public officials inside the state entity that decide the contract, and they could be family, they could be bribing, they could be friends, but they award the contract in an unjustified manner. So that is collusion. But there is another modality that is a coordination between two of the competitor companies. For example, this has happened in Peru with medicine, when buying medicine. The providers, they just agree on the price, and they simulate competition. So they agree on the price, they raise it a little, they will get more money than they should, and they simply they take turns on winning the contracts because they are the sole providers of that item. So if we were looking to detect collusion, it is different than looking to detect this price coordination. So one has to be really specific in what one is looking for in order to design the algorithm. So we were like investigating all these modalities of corruption, and we had to decide one. So why corruption in public contracting? Well, I talked to you about the Lavajato case. So it was like in our minds, but also because of that availability. Because in Peru, we have a tendering and public contracting system called SEACE. And we surveyed all the databases, and this was a big database, and it looked, I put availability because it looked like we could obtain the data, but we had to break protections from this database, like the CAPTCHA, bypass IP blocking, etc. So it's available. Okay, and now that we had a more concrete vision of what we were looking to work with, we had to model, to start modeling. You know, to build an algorithm is also called data modeling. So how do we express these ideas we have about corruption in an Excel sheet, so that a computer can understand it? And we, in the research, it surfaced a theory and an application by Mihaly Fazekas, a researcher from Cambridge University, that we have used to develop Funes. It's like the theoretical base. So this is a diagram in one of Fazekas' papers. It tries to put in, like I said, in an Excel sheet, all the suspicions that one may have about a contracting process, a tendering process. So we have the contracting body, that is the state entity. In our case, they are state entities. We have the supplier. These are all the companies that are looking to provide. We have the contract itself, that is the communication between the state entity and the supplier in a specific situation. And assuming there is corruption, we have there is corruption, and being more specific, assuming there is collusion, there is a particularistic tie. The connection between the contractor and the contracting entity. So out of this diagram, this abstraction of the tendering process, we can get risk indicators. This would be behavior that tell us something is suspicious. It might not necessarily be corruption, but it is suspicious. Okay, so we have I have put here a list of risk indicators, a small list because In Fonseca's papers, I think there are like 40 risk indicators, and people, depending on the context, can find more. And in fact, like the traditional journalistic investigation is based on that. Like what seems suspicious is sometimes it can be expressed in data. Okay. So, for example, of the political connection risk indicators, we can have that the contractor, the company is a political donor or militant of the party that controls that state entity. So the contract could be like some kind of favor in that political connection. Okay. On the supplier risk on the company side, we could have an indicator of that the proportion of income that the company wins from the state wins from the state in respect to this state entity is very high. I mean, if the company only wins contracts from this state entity, it would be strange because he should be trying to provide to more state entities unless it has some kind of particular tie that makes it easy to win in that state entity. So this is like, the other indicator is a yes or no indicator. It's like, it happens or it doesn't. But this one is like a numeric one. So it could be that this company wins 100% of its contracts from this state entity, or it could be that it wins 90% or 50% or 10%, and we can see this is like a more numeric indicator. We will see what this means when modeling. When making the algorithm. And another example of indicator, this time on the tender side. Okay, remember these examples make reference to this diagram. So another risk indicator is if the tender has a single bidder. That means that it's supposed to be like a competitive market and an open competition, but only one company is trying to get it. And if it's a single bidder, it will usually win. So, okay, this is like the theoretical, the design part. We know what we're looking for. We're looking for collusion. We kind of know how to detect it with data, but we haven't done anything yet. So let's get concrete. Okay, the concrete part I put concrete because data is it's kind of abstract. It's like you see it on your computer, but in algorithm modeling terms, this is getting concrete. So the data, where is it? How to get it? What does it mean? I mean, Ojo Público has not built these databases. They are public databases. They have their own name, their own naming systems. They make reference to laws. It's important to know what do they mean if we want to model. How to integrate it? Data comes from different sources, and we will see examples of each state entity that manages, for example, the state entity that manages contracting uses different names than the state entity that manages who won a political circumscription. Okay. Having lots of data and how to manage that, and if the data makes sense. So this part is pretty fun. It's what we had to do in order to just get the data and build the algorithm. Okay, so where is it? We mapped all the sources that were related to our project. So this is a screenshot of the actual spreadsheet we used. This is Janko, one of the team members, made the last modification, well, a long time ago. So the title of the database, the state of getting it, description, what project had it come from, because we already had data. available. So this is the name of the project. Here is Fondo de Papel. The type of database, because we had public database and database that had been leaked to us. And the last time it was, it had been refreshed, the data had been, I have forgotten the word. Okay. So we mapped everything, and from that, we kind of knew what we had, what we could get, and we had to prioritize what data to get. Okay. This is another spreadsheet that shows us the risk indicator. For example, this is a single bidder contract. The definition of the risk indicator, if we have it or not, and the data source for it. Well, and this is like more to understand what indicators we have and which we don't. So there are indicators that come from a single source, and there are indicators that come from by integrating different databases. So we're organizing the data we have to see what we can do. Okay, now that we know where data is and what we can do with it, how to get it. This is the interface of the Peruvian tendering system. Well, there are actually a couple more tendering systems, but this is the one that has most data. And you can see here the CAPTCHA. So in order just to make a query and know what tenders were or what tenders are right now, you have to pass this CAPTCHA. And the system is very slow. It tends to stop working randomly. You know, like you wait 10 minutes for a query and it never returns. And so aside from the work on understanding the data and modeling it, there was a lot of work in getting the data, in scraping it. Okay, and it took a lot of time. So yeah, data availability is really important. Okay, how to integrate it? This is another screenshot from this contract, from the tendering system. And here we can see the identifier of a local government, the district government of Catka. And you can see that it is written with double C's and double C's again, 2 times. And the upper screenshot is the database that holds who won, what political party won in each district. So here, Catka is written with 2 C's at the beginning, but 1 C at the end. And this other database is called InfoGov. It has no numerical ID available. So you can only make the matching, the integration by name. And so like this case that it won't match by name, you have to do it like by hand. It won't match automatically. You have to do it by hand. Well, there are like, I don't know, 500 cases like that. So 2 state entities, they manage the names in a different way. And there are many instances of this. So it is not only a modeling, like a data science work, but it is also like only managing the data. It takes a lot of time. Okay, and finally, does the data make sense? The data we are getting from the state. And okay, this one we have to pay attention in order to understand this screenshot. So here in the link, you can see a 11-digit number like 20, 48, 75, 94, 67, 0. That's the ID for a company in Peru. It's called the RUC, the Registro Único de Contribuyentes. And this is a specific contract it has been awarded. So you can see the amount of the contract is like 20,000 million soles. and our currency is not, it doesn't work like that, you know. It's like 3 soles is $1. And if you look closely, what has happened is that the ID of the company is the amount that it has been awarded according to the system, to the government system. Yeah, and we have a lot of instances of this. You know, the data it doesn't make sense. It's dirty, and it's weird because the state makes decisions based on analyzing this data, and I don't know if they clean it like we do. And well, it brings a lot of questions, right? Like, but that's another subject. Okay, so you can see the problems that we have and the solutions that we gave. A lot of work in this part. The documentation part too it was a lot of reading the laws that define the systems, the state systems. And this last part about data making sense, it was detected by analysis. I mean, like by simple analysis, like making rankings, like, oh, what's the biggest contractor, you know, and you rank it the top 10, and you see a company that a small company in the top 10, and it's because it has been awarded like 20,000 million by an error in the system. So what we learned a lot in this part because we hadn't worked with data with the objective of modeling, of making an algorithm. So in order to model, you have to understand precisely what the data means. And this understanding came before analysis. Well, it was an iterative process. So we tried to analyze it, and then we realized that we didn't exactly know what it meant. So we were forced to understand the data inside out. Okay, another lesson we had is that the data was too big to be open on Excel, too big and too complex. I mean, it could not fit only on a spreadsheet. It was like 10 or 20 spreadsheets. So we needed new tools. And Janko, who is a journalist, he learned to use R. It's a programming language made by statisticians and designed to analyze data. So there was this need of new tools and of developing new skills. Okay, and also that simple analysis go a long way. So we may think that that we need refined analysis like statistical models or machine learning models, but you can get stories just by doing rankings, you know, by trying to understand your data. For example, mapping these mistakes would make a great story about the quality of state analysis and also of their database systems, because yeah, there is more context to this. Like this is a special type of contract that should not pass like I think it's 10,000 soles. So the system should know that, but it hasn't got like quality checks. Also that analyzing and understanding the data leads to detail. So we started once we had the data, we started going beyond our design, in the sense that we detected new risk indicators specific to Peruvian data. You know, once we understood the systems, we could see like, for example, there were in some documents of the tender process, there was the ID of the public servant that was managing the process, but you had to be like really looking for something in order to find it. but with that ID, we were able to find like husbands and families that were, the husband was the owner of the company and the woman, the wife was the the public servant managing the process. So it's important once you start diving into the data, you will find a lot of things. Oh well, this I already talked about this when I talk about analysis. So there were like stories on the data management itself, like invalid data, missing data, and security problems. Okay. Okay, so at this stage, we have the data and we have like the risk indicators. So we have and we have understanding of the data. So we have like the raw materials to make a model. And once we get the model, we will get like results. But how do we know if they are valid? And how do we communicate it to ourselves, to like, for example, me as a statistician, how do I communicate it to journalists and to the public? Okay, so this is like a language problem we had for a long time, like the whole duration of the project. That was, is it an algorithm or is it a model? Because like people that don't do data analysis, they are accustomed to the term algorithm, right? But people that do that analysis will most likely say model. And and well, they like mean different things. Algorithm, it gives the impression that the computer is doing everything, a series of steps, and that it will get a sure result. But modeling implies the role of the person that is modeling, that is taking decisions and making assumptions about the data. So it's an interesting problem in communication. Well, the model FUNES, the algorithm, is a group of generalized linear models. Basically, the data, the risk indicators go in, and it outputs a single number that it's similar to a weighted sum, like an average, but with weights of the risk indicators. I will explain more about the model in a minute. So, I didn't know the term traffic light. Like in Spanish, we use the traffic light. If it's green, you can go. If it's yellow, you should stop, and if it's red, you should definitely stop. So when using risk indicators in many fields, like in money laundering, in corruption, etc., you usually just sum the indicators, right? It's 1 or 0, and you get a score like from 0 to 7 or something like that. And when doing that, you're assuming that the risk indicators have the same value, like they all come with the same risk for saying so, right? So a weighted sum, like assigning a weight to each of the indicators, is like a little more refined than a traffic light. Okay, so this is what we were pointing to, like this is what we were pointing to, and these weights are found by the model. We will see it in more detail in the following slide. So, okay, we have the data, we have the model, and we have its output. What does it give us? The most important for us was that it leads us to new cases. So the hope was that the output of the model, if we ranked by corruption risk, we will get the most interesting contracts on top, and we would manually check them and see if there is something. Also, the advantage of a model is that it gives this complex and big data a human scale. All the risk indicators, like we had, I think 22, were summarized in a single number. So instead of trying to look in multiple dimensions at the same time, because with the risk indicators you can, sort by the one that has this risk indicator and this other, but there are 20. So how do you see everything in a single number? So the role of the model is also to simplify the data. And finally, what we wanted was the model to interpret the data for us in its way, and this kind of requires someone that knows the model, how the model works, to explain why something weighs more or weighs less. And this would also allow us to understand better how risk or what is risky in a tendering process. Okay. Okay, but we're assuming that the model is correct, that it is useful, but can we believe in it? So the model needs to be validated, and there are two approaches to validation. One is called black box validation, that where we simply care if the model will give us new cases. So does it give us new cases or not? That's the criteria we use to judge it as useful or not. And the other approach to validation is white box validation, which means that someone has to understand the model inside out and see if it is making sense, if this machine is working all right. Okay, do evaluation metrics on holdout dataset look okay? So a specialist in statistical modeling or in machine learning will know what this means, and the other one is, do the model coefficients for risk indicators make sense? This means is if the model is, for example, giving a lot of weight to something that we know from experience that it shouldn't. Okay, and here comes we're going deeper into detail to the model, because when we began talking about Funes, we talked about we're trying to detect collusion, right? So, but collusion is corruption in public contracting in this specific modality. It's a hidden phenomenon. I mean, we have detected some cases. The justice system has detected some cases, but it has not detected all of them, because these people are trying to hide what they have done. So we call this in modeling a latent variable. You cannot observe it precisely. You have to use other things that are similar to it in order to approach, but this approach is imprecise. So because of this, we shouldn't trust too much in white box validation, because we are modeling using proxies and not the exact thing we are looking for. Yes, so it gets complicated. Okay, let's look at the model and the proxies. So this model is also, it inherits from Fasecas, who proposes using an ensemble of linear models, of generalized linear models. So we make the same, but we make some modifications. The proxy variables are a single bidder that is what the risk indicator I told you about, that to the tender there is a single company that wants to win it. It's strange. And other proxy is that a single offer is evaluated. So there might be many bidders, but only one offer is considered valid. And the third proxy is the winner's share. It's the winner's share. This is the other risk indicator I explained previously. If the company concentrates a lot of the contracts of this state entity, these three indicators, they are proxies. They are not corruption, but they are kind of suspicious in a very strong way. If we make some assumptions about the competition levels of the market. So it is explained in a lot more detail in the FASECA's papers, but again, these are all assumptions, right? So, well, and these are the details that if anyone wants to understand better, you can ask a question. And basically, the risk score we assign is a weighted sum of these of the coefficients of these models, of the each model, each proxy model will like give its opinion on a risk indicator, how risky it considers it. It's better to see it on a graph. In Peruvian public contracting, we have these tender types. They have their specific rules and, well, are the tender types. So by using two proxy models, we can see the risk score contribution, the weight assigned to each tender type. So sometimes they agree, like in this tender type, and sometimes they don't. They go to different directions. Like this way says it's risky, and this way says it's less risky. So, this is like the kind of thing that internal validation, white box validation, will tell you this shouldn't happen. If they are pointing to the same thing, they shouldn't like contradict themselves. So this is a specific kind of variable, like the tender type, that it's a yes or no variable, a binary variable. So it is either a direct contract, like this contratación directa, or it is not. But there are also numeric variables. And this is the risk contribution according to recurrence time in days. Okay, so I have to explain recurrence time. Recurrence time, that is a risk indicator suggested to us by a public prosecutor. So this public prosecutor told us that he had seen a public official accused of collusion. So he resigns to the state entity, in the north of the country, and goes to the capital. And there he gets another job in logistics and starts contracting again. And he had seen that many of these people contracted with the same companies that they had contracted in their previous position. So, like, they moved and the companies moved with them. So this suggests a relationship, a particular relationship between them. So we had the data to build that recurrence in the relationship in the relationship. And one of the risk indicators of that relationship was how long did that recurrence lasted. So we can see again that in this case, the risk assessment between models agrees. So both models, one for single bidder and one for winner's share, assign a growing risk when this relationship lasts longer. So these are interesting things the model tells us, right? This is like what we would do to interpret the model. Okay, and this is an example of black box validation. So we said that corruption was like a hidden phenomenon. But there are some cases that are discovered and are judged by the judicial power. So we collected, like, I think they were like 200 cases. We call them validation cases. And we linked those cases with the contracts that we were analyzing. So we could know how much risk score was assigned to each of these cases. So you can see that the idea is that these cases should have more risk score than the other cases. It's a kind of black box validation. Would our algorithm have detected or have suggested that we investigate these cases or not? So they are classified here by how we found them. Yeah, you can ask me afterwards. There are some from the public prosecutor's office, some from the contracting tribunal sanctions, etc. And we can see that there is a group that indeed is on the tail of risk. The risk goes up there. I should have labeled the histogram. So there is a group that indeed has like high risk, but there is a big group of cases that is like a standard risk, for saying so, and we wouldn't have looked at it. So what's happening here? Yeah, this is something like we have to analyze and understand why the model isn't giving enough risk to this case. Maybe we are missing some kind of risk indicator. Maybe the model only detects some kinds of collusion and not others. So yeah, it's interesting part of modeling to validate like this. And well, maybe the most important criteria to judge our model is if it leads us to new cases. So because we can do a lot of this analysis, but our objective was not academic, but was, hey, can we make an algorithm that points us to corruption cases we haven't seen? So this is a case study that hasn't been published. So when we finished one of the, I don't know, I think it was the third, fourth version of the algorithm, because we were refining always. I started looking at the risk scores, like simply ranking, and ranking by state entity. I had one state entity, right? And ranking by company. I had one company and the top one. So this top one company it had the indicator of that we call addiction, like the company only provides to this state entity. It has recurrence, like what I explained about contracting with the same official a lot of times. And it had a lot of direct contracts that meant no competition. It was awarded, by simply pointing to it because of an emergency situation. So I said, well, let's look at it. And I started looking at the documents of the tendering process. And on the documents the company presented to the state entity, it had a contact email. And the contact email of this first company had the domain of another company. Like instead of ojopublico.com, it was JournalismAI.info. It was weird. So I checked the other company that was also on the top 20 of risk. And I checked further, and it was also on the top 20 of risk, looking only by company, and was also like an addicted and recurrent provider of this state entity. And well, they were family in the end. The company of the email domain was of the mother, and this other company, the top one, was the daughter. And this state entity that was signaled by the algorithm had been investigated by Congress for systemic corruption. And so this is kind of like the hard validation of the model, you know. In fact, these two companies that the algorithm and manual inspection detected have not been considered in the Congress Commission. You know, they had pointed at other companies, like saying these companies are guilty of collusion with the public servants, but not these two. And well, it's a pretty case. You know, checking on the Facebook of the family and seeing the details. It's an interesting case. It hasn't been published yet. So our conclusion is that a model can be a new source. It gives leads. In the best case, it gives leads that we wouldn't have seen ourselves. You know, it isn't like another journalist, but it's like, you know, a strange kind of source. This is in the best case. But in the end, the story still has to be built through investigation and reporting. You know, you have to manually check all the documents, go and see the places listed, talk to the people. So this is what we concluded after building Funes. And right now we are still refining and solving problems we have with data. Okay, and this is more of a modeling part. So when we modeled this version of Funes, we have used what is called a supervised model, which means that that we give it the answer to corruption, like, and we make the computer like learn the patterns that point to this answer. That's a supervised model. But there are models that use no answers, because in this case we shouldn't be using an answer because as corruption is hidden, we don't have like clean information, like complete information. So there are approaches to modeling that do not need that. And this is what we would like to explore further. Well, that's it.
Gianfranco, thank you so much. This was a very extensive and wonderful presentation. I think it really showed the power of algorithms to be used as a force for good by newsrooms to unveil corruption, as in this case. And you have already pretty much replied to the many questions we got on the Telegram channel. So thanks to everyone on the channel who's dropping the questions. There were some about the weight of the model, of the scores in the models. People were asking, I think they're very impressed. So somebody was asking about how big is the team, which you explained it was 4 people, if I'm not wrong, working on this. Just to mention some of the questions that maybe are still open that I think are interesting. There was a question about how much time it took the team to develop Funes. So how long are we talking about as a time frame for this specific project? And also, I would add, using one of the questions, like if you have already identified different case studies that the same like model could be applied for. So is there anything other than corruption cases that you think a similar algorithm to Funes could also help the newsroom do some cool work on?
Okay, for the first question, it took us almost, I think, a year and 3 or 4 months until publishing the front page. But there is still a lot of work. You know, we had to like close the project sometime. And the second question, can you repeat it? I'm sorry, I guess.
Yeah, of course. I was wondering if what you have learned during this project with Funes already gave the newsroom other ideas about how to use the same AI principles for different kind of journalistic work as well.
Yes. In fact, I have been working these last couple of months with a human trafficking project, checking on like Facebook work ads in Facebook groups. And it's the same like schema of trying to build risk indicators. this is an approach of modeling like that people call feature engineering, but we have like it's internalized now in the team. They ask me, hey, can you make like a mini Funes with that? And it helps systematizing what you're looking for. Yeah.
That is excellent, super interesting. And I think another question that we got on the chat from Telegram, and sorry to everybody who's dropping the questions on the channel if I'm not able to remember all the names, but really appreciated all the questions you're sharing in there. But I think the interesting question was about whether the scores that the algorithm gave you for each company, have you considered, or maybe you have also done it to share those scores directly with the public, or they were just used internally to inform journalists for their investigation?
Yes, that's an interesting question, because this score is like a suspicion, but we're not going to condemn people based on the algorithm opinion, right? We put a lot of work in like investigating in classical journalistic sense. Yeah, that's why we didn't want to share publicly the scores. There were also some problems with bias, like when we were modeling on the first iterations, the model would point a lot of risk on a small state entities like district municipalities, because they have a lot of collusion characteristics. There is a lot of contracting between family and political party, the political party that has won, but it was only pointing to that. That's a problem. It also got crazy with really big companies, because most companies are small, but there are giant companies here, like everywhere, and the model was having trouble interpreting that. It's the problems that appear on data modeling. Yeah.
Thank you so much. That's super interesting, and it's a really interesting point as we go through bias, which is a topic that will be discussed across the week of the festival, showing how bias emerges even on a case like this, when maybe it's not the first thing that we would think of as a potential consequence of this work. It's really interesting, and it's really admirable, the work that the newsroom at Ojo Público has done to take all of this into account. So I think it's about time to wrap up. This was a wonderful session. The former statistician in me thoroughly enjoyed all the technical parts, so thank you for that.
Oh.
Compliments for the newsroom. So we hope you'll bring them back to Nelly and the rest of the team, because this is really impressive work. So we all hope you will continue doing more and really just showing all of us what actually algorithms can help us do. So thank you again.
Okay, thank you, Mattia.